Okay, in example 8, we have the integral from 0 to 4 of 5 over the square root of x dx. Now, here, we still have an improper integral. One of the reasons why we have an improper integral is not because it doesn't contain, well, clearly we don't see no limits of integration that it contains infinity or negative infinity, but rather the function is discontinuous at x equals 0. Right, so note, if you wrote this function, if you wrote the integrand part, f of x is equal to 5 over square root of x, this function f is undefined at x equals 0. But if I chose any other value from 0 other than 0 in the region from 0 to 4, can I evaluate that integral or evaluate the function? Yes. Right? On the interval, 0 to 4, it's like a half open interval. Right? It's like half open, half closed. The left endpoint is not included. We can't include 0. But on the interval 0 to 4, where 4 is included, 0 is not, the function is defined. All right, so there's a little rule that we can use. We can say that if you have an integral of the form of a to b of f of x dx, and like, let's just say that the function was undefined at a, then this is equal to a limit as I use a different letter here. We just use a dummy letter, call it t. We say t approaches a from the right of t to b of f of x dx. Similarly, if you have an interval, a half open interval, let's say where you're including the left endpoint, but you're not including the right endpoint, and let's say your function is defined on it. So I wrote this backward. It should have said f is defined on that interval. Then for the integral a to b of f of x dx, this can also be rewritten using a limit. You say the limit as t approaches b from the left of a to t of f of x dx. And of course, when you compute these limits, if it converges, then you know that the limit existed, right? Limit exists, will converge. If you see that the limit doesn't exist or goes to infinity or negative infinity, then it diverges. All right, let's try it out. So the integral that we had was from 0 to 4 of 5 over square root of x dx. So I could rewrite it using this rule here, which I put a star on. We have that is equal to the limit as t approaches 0 from the right of t to 4 of 5 over the square root of x, or x to the 1/2. Now I can do a couple of things before I evaluate the limit. First, I can pull the 5 out of the integral, and the x to the 1/2, I could bring it up into the numerator. So we have 5 times the limit as t approaches 0 from the right of t to 4 of x to the negative 1/2 dx. All right. Let's try to find the antiderivative there. If we do, x to the negative 1/2 is just simply x to the 1/2 over x to the 1/2. From t to 4. Now, instead of dividing by the 1/2, we multiply by the reciprocal. So 5 times 1/2 is 2. 5 times 2 is 10. So we get 10 times the limit as t approaches 0 from the right of x to the 1/2 from 4 to t. So I'm just going to skip a line here. Let's just say I plug in my limits of integration. We're going to get 4 to the 1/2 minus t to the 1/2. All right. Now, what is 4 to the 1/2? 2. That's going to be 2. Now, it did say that we're looking at t approaches 0 from the right. So if I plug in 0 for t, can I evaluate that? Yeah, you can. Because at the end of the day, if you're approaching 0 from the right, you know that these values of t, they're bigger than 0. They're going to obviously be positive numbers. But at the same time, they have to get really close to 0. So if you look at a number line perspective, like let's say here are my t values. Let's say here's 0, and let's say here's 1. We're approaching 0 here from the right. So if I approach 0 from the right, then I'm looking at numbers like 1/2, a quarter, 1/8, 1/10, 1/16, 1/32. Those are all getting fractions that are smaller and smaller, getting closer to 0. So technically, yeah, I could plug in 0, because if you think about it, if you get a number like 1/1,000,000 and you take the square root of it, 1/1,000,000, take the square root, is going to be close to 0. So that being said, we are going to get 10 times 2 minus 0. Now, what's 2 minus 0? 2 times 10, 20. So is it converging or diverging? It converges. So it converges to 20.